All right. So here we go. We're going to work question number 6 right here. And now I'm going to reference a little bit of stuff we talked about yesterday. What would be the best form to solve this one based on the characteristics of the problem? What's the best method? Why?
It's because you can either exit out the y's or...
I gave you 2 characteristics yesterday. I want that to be the question you ask yourself. So as I look at the characteristics of the problem, what does it have that allows elimination to be a possibility? To have a coefficient of 1. Yeah, it's -1, but it's a coefficient of 1, right? What else? There's one other characteristic. We just had to check 2. And what's that called?
Standard form.
Standard form. Are they both in standard form?
Yes.
They are. Both in standard form, coefficient of 1, elimination should come into me being a possibility. That's just 2 characteristics, ladies and gentlemen. 2. Now, you didn't have the elimination piece before this, so I'm going to solve it in graphing, and we'll do elimination substitution on the next assignment. But I want you to see that, I want you to start thinking that way. What would be the easiest one? What would be the best one? What would be the most efficient one? What you're going to see is I want you to see that graphing works for all of them, no matter how ugly they are. Somebody bring me a calculator so I can graph it here in just a minute. All right, so we're going to graph it. And so what I'm going to do is I'm going to take these and I've got to put them into y equals mx plus b so I can graph it. Thank you very much. All right? And so if I'm going to solve for y, order of operations from? Think. All I got to do is keep looking around. I'm going to get more answers, huh? Nobody's saying it definitively like they can back it up. Why?
Because you're...
No, I asked her why.
Because you're solving.
So is that top to bottom?
Yeah.
Bottom to top when we're solving, top to bottom whenever we're simplifying.
Yeah. Didn't I say that? No.
Pretty sure you said top to bottom.
I meant bottom to top because you were solving.
No, I thought she said...
I'm pretty sure I said bottom to top.
You didn't. Anyway, we work from bottom to top because we are solving. That is correct. So we're solving for y. So I subtract because I'm at the addition subtraction phase. If I get out of the picture, let me know. Okay? And then I'm going to solve for y. Now I go up the rung to the multiplication division phase. And I'm going to get y equal to 1/2 x minus 2.
I got a question.
Mm-hmm.
You put yours in different forms, didn't you?
I did not.
No, like your the bottom shape when you solved it. Because that would have been 0.5, right?
Oh, I wrote it as a fraction.
That's what I'm saying. So,
If you write it as 0.5, you better be using the calculator to graph. Because otherwise, you don't have a rise and run. Rise is the 1, run is the 2. So the numbers of each numerator and denominator mean something. If you put 0.5, you don't have a numerator or denominator.
But Ross, did you not
I put
do
mine
the elimination thing?
No, I said when you had this assignment, you only had graphing.
Oh, yeah.
So that's why I'm doing it. I'm going to do them all in graphing, but I'm going to reference that stuff we talked about yesterday. All right, so this one's already good. This would be my y1. Now we're going to solve this one. So when I'm solving them, order of operations from
Bottom to the top.
bottom to the top. There it is. I'm at the addition subtraction phase, so I'm going to add the x, positive x plus 4, divide by the negative 6. Everybody good so far? Once again, minor infractions. You did not have to reduce that 2/3. You could have left it 4/6, but you have to have your sign correctly.
Something's like... Because I did all of them. I did everything right. I just Like, I did it the same way.
Well, I bet, I'm going to just tell you that I bet it comes from this right here, because this is going to be .666666667, and I bet you put .67 in your calculator.
0.7.
Oh, yeah, there's your issue. Rounding. It's like the one that we talked about yesterday, which was number 7 on the sheet, and I said the purpose, the graphing stuff is not hard, it's long, and it's tedious, and we had that problem that came out to .2222222, and when you put .2 in your calculator, your y-intercept's going to be a little bit different than the repeated decimal, so it's not going to be accurate. And so I guarantee you your answers were close, weren't they? They were pretty close. Yeah, that's what we're fixing to talk about. Put it into the calculator as a fraction. I took it to, oh. I'm sorry.
Good, Ross, the thing is still going.
All right, so put those in our calculator right now, and we'll check the points of intersection. I'll do it in just a second. I hope it's still charged.
It's okay, we have the charger.
It's an old one. Drew, will you let him back in? With him. Ask him if he'll let you back in since you don't have my keys. Okay. All right. So now then, those are the two equations that we're going to graph. All right. So go to y equals parentheses. Parentheses. Now let's clear this out. Parentheses, 1 divided by 2, close parentheses, x minus 2 is the first one. The next one is going to be the one that requires a lot of parentheses. So negative 1, open parentheses, negative, open parentheses, 1 divided by 6, close parentheses, x minus, open parentheses, 2 divided by 3, close parentheses. Now, my 4 is 6. I could put those in as 4 and 6, but in your calculator it will take care of those repeated decimals, which your answers will be a little bit off. That's why I want to try and answer your question to where you put 0.7 because it was 0.67. Your answers are going to be fine based on that, except it's going to be a little bit off from the other one because there's a difference between a y-intercept of 0.7 and a y-intercept of 0.66666667. That's going to go further down the line. So that's where the issue is. We'll graph both of them. Alright, and then we're going to use the trace feature to find it. So I'm going to go second trace, scroll down to intersect. We do not, that's correct. I establish the first one, and then I scroll past the point of intersection for the second one. And there it is, 2, negative 1. Alright, good to go?